Hello, everyone, and welcome back to another installment of our workshop series, Cybersecurity Pocket Edition. And today, the Q Project is hosting Arduino with motion sensors. So, before we get started, you're going to be needing a Mega 256 2 yeah 2560 R3 Arduino board. You can use this for other ones, but this tutorial is going to be using this specific board. You're going to be needing three male to female jumper wires and one PIR motion sensor. So there will be no slides today, but I'm going to do a quick introduction on how the PIR motion sensor works. So basically, with this motion sensor, there's two slots that exist that are IR compatible. IR is infrared radiation. The P in PIR stands for passive. So basically, it constantly sends out a infrared radiation detection signal. And so when an object comes into view, the heat from the object gets detected by the infrared radiation and creates a positive differential change between the two slots. And so when the warm body leaves the sensing area, the uh, slot generates a negative differential change between the two slots. And that's when the change pulses are emitted from the pin of the sensor. So today, we're going to be using this sensor and modeling it on using a Arduino. So let me first share um, the pin out for the PIR sensor. Let me share my screen real quick. So this is what we have here. Um, the left one is ground. The middle one is the digital output. And the right one is VCC, which is basically 5 volts. On this endpoint right here, we have different mode controls. For example, one of them um, sends a signal or resets the time after each sensor is detected, and the other one has a repeated sensor, so it um, continues the timer when the change is detected, no matter what. So let me actually go to the actual um, what do you call PIR to the actual Amazon page. They explain it much better. I'm not doing any kind of um, promotion for these guys, but here, if you have the actual pinout right here, high, low output, ground power and stuff. And this jumper here, if there's one mode, single trigger mode, the time delay is started immediately upon detecting motion. Continued detection is blocked. And there's another mode called repeatable trigger mode. Time delay is restarted every time motion is detected. And then we have different kinds of time delays as well as the actual sensitivity. So we have this right here. Not sure if you can see it. So the left one would be the time delay, and the right one would be the sensitivity. So if we want to decrease the delay as much as we can and increase the sensitivity as much as we can. So what you're going to do with both of these, you're going to take a small screwdriver and go all the way to the left. If you don't have a small screwdriver, that's fine. It still works out with it, but you won't get enough responsivity from this. So let's begin how everything works. So we have the board right here, an Arduino Elegoo Mega 2560 R3 board. And what we're going to do is first we have to get the give the sensor power. So we're going to take a cable right here and hit it and put it into a 5-volt pin at this point. And then we're going to insert this. We're going to insert the end of what we just connected to the 5-volt output or input on the sensor, which is going to be on the top right when the um, the sensors like the timer and sensitivity are on the bottom. So let me share my screen again. So you can put it on the top right here. That's where the power is supposed to go. Now we're going to take the white one or whatever next cable and put the pin inside ground, into some ground. I'm going to put it on the right next to the 5-volt, but you can put it anywhere you want. And then you're going to put the female end on the ground side, which is going to be on the top left. And that's what we have there. Do I have everyone right now?
Yeah.
Okay. Now the sensors gain power from this board, or theoretically. Now we take this last wire, we put the pin. Now this when we insert the pin, it's very specific to which pin we want to use it for, depending on the code which we're gonna go over right now, a little bit later. So make sure you look online at what your pin or what pin supports interrupts or digital interrupts. So be sure to check that out. So what I'm going to do is take the pin end, the male end, and put this in port or pin number 3, which would be on the other side of the wires. So we have this right here. And then put the female end in the middle of those, in the ground and the power, so we can get the digital output of this. And voila, your sensor is officially connected to your Arduino board. Now, let's look into using the math or the code which this sensor runs on, so we can actually calculate when it is changing. So let me open Arduino IDE for Mac. This works on any system, Linux or Windows. We have all 3 systems in this tutorial right now. So they'll let me know if there's any problems. So we have a Arduino empty sketch right here, and we're going to be editing this code right here. So let's start with defining some numbers. So we have hashtag define motion digital pin 3. So this defines the digital pin for the motion sensor to be 3, which is what we pin our motion sensor on. Now let's we're going to have a Boolean called LED state. Just let me explain a little bit what our end goal is. There's a built-in LED on this Arduino board, and whenever the motion sensor is detecting motion, the LED is going to light up, and that's what we want it to do. So this Boolean will be used for holding the state of the LED. So inside setup, what we're going to do, we're going to set the pin mode of LED built in to output. So we want to give an input to the LED, the built-in LED, and it will be basically an output or actuator. That's what it's called. So we have now the next one would be pin mode, motion, digital pin, input. Now we're going to, instead of just regular input, we're going to put a pull up. Basically, this allows for interrupts. And now we want to attach the actual interrupt. Digital pin to interrupt motion pin change LED. Okay, do I have everyone here? Okay, good. This middle one basically tells us this is the function what we want to run. So I'm going to put that here. This is the pin we want to interrupt or set a digital pin interrupt. And this is when we want this function to be called every time there's a change in fluctuation. So now we're going to code this. We're going to set the baud rate, which basically tells us the input at which the Arduino is sending information back. It's going to begin. We're going to use the default one. It's 9600. Baud rate is basically symbols per bits. Actually, bits per symbol or something like that. Basically, higher baud rate allows for faster communication or a certain degree of communication, which allows for different speeds at which information is passed through. Print ln. Now we're going to test something. Just a quick print statement beginning. We're going to digital write LED built in to low. Low is basically off for the LED. High is on for the LED. And we're going to set the LED state initially to false. And we want to delay 1000. Now let's go to the change LED function. We're going to do if LED state. We're going to write digital write LED built in to low. We're going to set the LED state to false because it's on right now, so we want to turn it off. And then we'll do a serial.print ln to say that motion is no longer detected. Now we want to do that same thing with this. So let me know when you guys are ready.
Hold on, I'm gonna need a minute or two to catch up.
Yeah, same here.
That's fine. Take your time.
I think I'm ready. Got everything written down.
Okay, that's good.
Is it important for the motion sensor that we turn both of those screws all the way to the left? Because I'm gonna have to
No,
find a screwdriver.
no, it's not important. I should have mentioned it before, but um, all it does is decrease the time so that when you're moving your hand in front of it, it won't stay on after your hand is gone for
Oh,
a long
okay.
time. And for the sensitivity, um, it goes up to 7 meters according to whatever we bought it from Amazon. So that's just your sensor range, so that doesn't matter much.
All right.
Okay, I think I'm good. Also,
Okay, so that's it. That's our code. So let me share my actual screen, my entire screen. So I'm going to be using this code. It's the exact same thing with just more comments. So um, I wanted to share my entire screen so you can actually see the commands I run. That what I use to click to actually run this code. So you're going to take the wire to connect the Arduino to your actual laptop or desktop. So do that now. Okay. Does everyone have it plugged in? Okay. Now what we're going to do, you're going to go to tools. You can go to board, choose your board. Mine is the Mega or Mega 2560. My processor is the 250 2560 again. My port would be this one, um, which is already set. Make sure you have that there. My programmer is AVR ISP MKLL. Um, just to put that out there. And now we're going to go to click this button. We're going to verify it first, see if the sketch compiles. Now we're going to upload this code. And it should be done uploading. So let me actually share what's happening right here. So you have the LEDs at this point right here that's showing if, if there's motion or not. So right now it's off. Now, if I move this around, you can see that the LED is turning on right here. And you can see that the LED next to TX is being on sometimes along with the built-in LED. The built-in LED is what we control. This TX LED stands for transmitting. So basically, it's transmitting data back to this our laptop. So if you open the serial monitor, we can just mess around with this. Motion no longer detected. Just keep your hands up there. Bam. Motion no longer detected. Motion detected. Motion no longer detected. Like that. So does everyone have that?
Let me check.
Did you just hit verify or did you hit upload as well?
I hit verify and then upload, but you can
Okay.
just go upload straight because it would verify for you first.
My thing's not doing anything. No lights, nothing printing on the serial monitor.
Do you have serial.println? Oh, actually, can you share your screen?
Okay. Oh, can you enable
Oh.
that?
My bad. Go ahead.
Let's see. So, can I share the code only, or does it have to be this whole screen?
Whatever you need. We can do code if you want.
Okay, so because here's the whole screen. Oh, that didn't work out. Let me just maximize this.
Okay. We have the digital pin input, output beginning program, LED built-in, false, else. Okay. Can you show me your actual Arduino?
Yeah. Uh,
Yeah, you're gonna have to turn off your background.
I think it's a issue with the code though. Because I think it doesn't. It's not running the change LED function because we're not calling it.
You're calling it by attaching an interrupt on the top.
Hmm.
Do you have it right? Like the power and ground?
5 volt ground, and then digital 3 for the middle pin on the sensor.
Yeah. Um, make sure that the power is on the right, as if is on the right pin, as if the pins were on the top.
Yeah.
Pin.
Yeah, I think but like I'm not even getting the print statement. Like it should still print that no matter.
Is the
It-
LED working? Like if you move your hand in front of the sensor?
No. Maybe I misspelled it.
No, you should be good. Try a different sensor. Sometimes they're pretty cheap.
I got mine working, but like you were saying, it's pretty laggy without changing
Yeah.
the what is it, sensitivity.
Oh no, the time.
Yeah.
You need like a small screwdriver for that.
I'm gonna go find one.
Oh, it would probably help to select the right
Oh,
thing over here.
yeah. Okay, now it works.
Let's see. Uh, huh. Okay, was working. I see what you guys mean about the like delay.
Yeah. Oh, instead of saying motion no longer detected, you say motion detected for the LED stay equals true. Oh, that's why the LED wasn't working. Your code was wrong. On the bottom, right here. Yeah, right there. This should be true, and you should cross this out.
Oh, so, okay. On the true one or the
Here, let me share my screen again. Right here. This state was wrong. That's why it wasn't working.
True. Okay. That's right.
Is it working now?
Yeah.
Okay. Well, thank you for joining us. That's our entire workshop. But later on, we're going to be using this as well as in ESP8266 to build a deauthor. And so it will, what our end goal is to build a dynamic deauthor where whenever something triggers the motion sensor, it will deauthenticate anyone nearby from the Wi-Fi. So it's going to be a fun project. Thank you, and tune in for more Q Project cyber events.